Hello, guys. Welcome to Ramta Solutions. Welcome to your past paper series of sequences and series. Today, the paper that we are looking at is the Mathematics Paper 1 from the Western Cape, the Cape Winelands District. This paper was written in September 2024. Because this is an exam paper, let's look at some few instructions before we proceed. It's important that in your examinations you remember this. We're going to read a few, three. That's instructions 7, 8, and 9. Just three instructions. But all of them are important. Okay. In fact, we should read maybe, three. It should be 4, 7, and 8. Oh no, 4, 5, and 7 would do. So instruction number 4 says, clearly show all calculations, diagrams, graphs, etc. that you have used in determining your answers. Instruction number 5. Answers only will not necessarily be awarded full marks. Instruction number 7. If necessary, round off answers to 2 decimal places unless stated otherwise. Okay? So, remember guys, try to show all your calculations, graphs, and anything that you have used in determining your answers. That's very important. Okay? All right. So because this is sequences and series, it's normally question 2 and 3. So here is it. So question 2. And by the way, we should thank testpapers.co.za for their archives of past papers. Right? All right. So let's see. So question 2. So question 2 says 2.1. 2.1, let's read. On the first day, Brett played an online game for 12 minutes. The second day, he played for 12 minutes, longer than the previous day. That is 12 plus 12, right? He kept on increasing the time each day. The record of the day he spent, rather, the record of the time he spent per day is given in the table below. We can see the information. Now, if the time spent playing the game forms a quadratic sequence, you should highlight quadratic sequence. Determine the 2.1.1, the values of A. So what we have 12, we have 24, we have 40, and then 24 minus 12 is 12. 14 minus 24 is 16. Right? So 16 minus 12 is 4. So because this is a quadratic sequence, it means the second difference will be a constant 4. It will be a constant 4. 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 4 is 20. What is it? Is 24. Okay. 12 plus 12 is 24. 24 plus 16 is 40. 40 plus 20 is 60. Now, 60 plus 24 is 84. Remember, they gave us until 40. So it means A is 60 and then B is 84. Right? Perfect. Now, proceeding. Let's see. 2.1.2. 2.1.2. A formula, they say now determine a formula for the time spent on the nth day. You need to remember that this one corresponds to 2a. Okay, I don't like this. It's not clear enough. Let me perhaps use a green. This corresponds to 2a. This corresponds to 3a plus b. And this corresponds to a plus b plus c. Right? Perfect. Now, let's see. So now what we are saying is we need to find the general term. So we will say, what did we say? We said 2a is equal to 4, isn't it? 2a is equal to 4. This implies a is 2. Again, we said 3a is equivalent to is 12, right? So we said A is 2. So if you like, you can say this is 6 plus B equals 12. Therefore, B equals 6. This step is not necessary. But of course, to avoid mistakes, you can include it, right? Perfect. Now, 3A plus, not 3A, A plus B plus C, isn't it? A plus B plus C equals, let's go back to check. It is the first time, it is equal to 12. It is equal to 12. A was 2, B was 6, C, what is it? We do not know. Let's go to the next page. So this implies C is equal to 4, isn't it? This is because it'll be 12 minus 6. Maybe let me just say this. It's fine. Let me just write 4. It's 12 minus 6 minus 2. So that's 12 minus 8. Okay? Perfect. Now, we know that T sub n is equal to an squared plus bn plus c. This therefore tells us that the general term T sub n is equal to um, 2n squared. We said b was 6n and then c was 4. So you can prove this, okay? You can prove if this is working. I'm going to test it with term 3. I'm going to test it with term 3. So where does n I put 3? 2 plus 4. Let's see. You guys have calculators. 2 times 3 squared is 9. So 2 times 9 is 18 plus 18. That's 36. So this is 40. Let's check. The third term is 40. This means this is very correct. Okay. This means this is correct. Right? All right. Now, let's then head to 3. Okay, I should be using ethical one. So 2.1.3 says on which day determine on which day he played for 312 minutes. So T sub n is equal to 2n squared plus 6n plus 4. All right. So T sub n will be 312. Okay. Let's go. So what is this? 0 equals 2n squared plus 6n. 4 minus 312 will be minus 308. Dividing by 2 throughout, we'll have 2n squared plus 3n minus 154. So we're looking for the factors of 154. I know it's factors of 154. Let me change the color and the font size perhaps. Factors of 154, their product. Product of the factors will be, of course, 1 times 154, 2 times 74, isn't it? 74. Um, 70, 77. Yes, not 4. 77. 3 is not possible. 4 is not. 5 is not. 6 is not. 7 is okay. Let's try 11. It's possible. So times 11, it's 14. 11 times 14. All right. So yes, this one cannot work. 2 times 77 cannot work, but 11 times 14 works. So we will use this. Now we have 0 equals n minus 11 times n minus 13. Not 13, 14, sorry. 14. Now the bigger factor must take the sign of the middle term. So this one is the biggest. So it says n equals 11 or n equals negative 14. But this is not possible. Therefore, he played for, okay, he played for 312 minutes on On which day? On day 11. Okay, on day 11. So this question is 10 marks. We have, rather, so far we have covered 10 marks and we're able to do it in like 10 marks. So we're good. Proceeding. 2.2. You see, this is my favorite. 2.2. The sum to infinity is that. So the sum to infinity, let's see. 2.2.1, perhaps let me start there. 2.2.1, let me start here. Um, sigma from k equals 1 to, to infinity, 4p to the 1 minus k. So this will be 4p to the 1 minus 1 plus 4p to the 1 minus 2 plus 4p to the 1 minus 3 plus and so on. This could be simplified by saying it's 4p to the 1 plus 4p to the minus 1 plus 4p to the minus 2. If you like, you can say this becomes 4 plus 4 over p, right? 4 over p plus 4 over p squared, isn't it? Plus and so on. I'm sorry I didn't write it here, but let me add it. All right. Now, this, therefore, you can see our A is 4, but now let's get our R. This is T2 over T1. What is T2? It's 4 over P. What is T1? It's 4. Therefore, it means R is 1 over P. Now, the sum to infinity, the formula is given, guys. The sum to infinity is given. The formula is given. It is A over 1 minus R. It is provided in the answer formula sheet. Okay? So it will be A, we said it was 4, right? A was 4. And then what was R? R was 1 over P. Mind you, they said calculate the value of P if it is given that the sum to infinity is 3. Okay, there you go. Now multiplying throughout by this, we will be having 3 minus 3 over P equals 4. Then multiply throughout by P. Maybe it's better if I say this. Minus 3P equals 1. Minus 3 over P, sorry. Minus 3 over P equals 1. Then multiplying throughout by P, it will be minus 3 equals P. So we found that the value of P is negative 3. Happy? Perfect. Perfect. Now, let's see. 2.2.2. 2.2.2 says, is this series convergent? Explain your answer. Let's see. R is equal to 1 over P. This implies R is negative 1 over 3. So R is greater than negative 1 but less than 1. Therefore, the series is convergent. Okay, as you can see, this is negative 0.33. Okay, so the series is convergent, right? The series is convergent. Okay, proceeding. Let's see now. 2.3. 2.3, very interesting. An arithmetic series has a common difference of 3. Ooh, that's interesting. Has a common difference of 3. So we are good. The third and sixth terms of the series are respectively 3x minus 4 all over 2 and negative 3x minus 10 all over 2. So there's something that I want you guys to notice. We have term 3 here. We will need term 4, term 5, term 6. So this will be plus 3, plus 3, plus 3. So what I'm trying to say is that to get to term 6, we should be saying term 6 is basically term 3 plus our common difference 3 times. All right? In other words, term 6 is term 3 plus 9. Do you see this? This is one method of doing it. This is the easiest, hence the 2 marks. Okay, so what is term 6? Term 6 is negative 3x minus 10 all over 2. What is term 2? Term 2 is 3x minus 4 all over 2 plus 9. Right? Now we multiply throughout by 2. We have negative 3x minus 10 equals 3x minus 4 plus 9 times 2 will be 18. Okay, so negative 3x minus 3x equals negative 4 plus 8 plus 10. This is negative 6x. It is equal to 18. It is equal to 12. Therefore, is it really 12? Let me see if I made any mistakes. 10, 4, 0, 9, 18. Okay, my mistake. 18. 18. Here is it. 18. Thank you. So it's 18. So this is 28 minus 4. So this is 24. Therefore, x is negative 4. Indeed, we were able to prove this. Otherwise, you can do this by, I think I should also do the second method, but you don't have to. It is that one where you use, you can use, what is this? You can solve for x simultaneously, right? You can solve simultaneously because there are two equations. You can solve for them simultaneously. Okay, so we can also use that. I also like that as well. All right, so let's not do that for this one because of its 2 marks. Let's just leave it here. Right, now 2.3.2. Let's see. This was 2.3.1, by the way. 2.3.2. Hence, calculate the first term of the series. Ooh, you see now, this is very interesting. I want you guys to remember something. So, you see, now they want you to calculate the first term of the series, right? They want you to calculate the first term of the series. I want to show you something here. You do recall that term 3 or Tn, let me show it to you. T sub n is equal to A plus n, all right, minus 1 times close times d. All right. So now if we say T1 or T3, not T1, let's just say T3. So T3, you still remember T3 was, let's say this A plus 3 minus 1. What was the value of D? The value of D was 3, isn't it? And the value of T3, if you recall, it is 3x minus 4 all over 2. Let's go. It is equal to A. 3 minus 1 is 2 times 3. It's 6, isn't it? All right. Now, multiplying throughout by 2, you will be having 3x minus 4 equals 2a plus 12. Okay? Then what do you have? You still remember that you said x was equal to 4. We could have done that as well here. Okay? But it's fine. Let me just substitute it. This will be negative 4 minus 4 and then minus 12 equals 2a. So what is this? Negative 12. This is negative 12. Negative minus 4 is negative 16. So it's negative 28 equals 2a. Therefore, we can say a is, it looks like 14, isn't it? Not just 14, but negative 14. All right, a is negative 14. All right, a is negative 14, isn't it? A is negative 14. Right? So this is us now. We have found 2.2.3 and 2. Now we need 2.3.3. Let's see if we can cover this in less than 25 minutes. Now 2.3.3 says determine the sum of the first set of 30 terms of this series. Ooh, do you guys hear this? The sum of the first set of the 30 terms of this series. Sum of the second set. So what we have here, we have sum of the second set of the 30 terms of this series. So this means we're looking at sum of 30 will be sum of first 30 plus sum of second 30. Okay, so sum of first 60, do you guys know it? I don't think I know it, but we can find it, right? So we'll say sum of n equals n over 2 into 2a plus n minus 1 times d. Remember, guys, this formula is also given. So now let's see. For the sum of 60, we will say for sum of 60, we will say n, this is 60 over 2 into 2. What was the first term? It was negative 14. And the number of terms we said 60 minus 1 times common difference was positive 3, isn't it? Yeah, positive 3. So let's see. What is this? This will be 30 times minus 28 plus 59 times 3. Close, close. So what is this? This then becomes 4,470. Now, sum of the first 30, what is it? It is again 30, right, over 2, because this means you're starting from term 1 to term 30. And then what was the first term? It was this negative 14. And then it is 30 minus 1. The common difference was 3. So let's see. This one will be 15, open bracket, minus 28 plus 29 times 3. So what do we get? We get 885. We get 885. Therefore, using that formula, you see, using this formula, we can therefore say sum of 30, sum of the first 60 was 4470, sum of the first 30 was 885, and then sum of the second 30 is a node. So 4470 minus 885 is 4470 minus 885 is equal to sum of the second 30. So therefore, this is 3,585 is equal to sum of the second 30. Right? If we knew the 31st term, maybe we could have just done this without any waste of time. And I think you can also find it, but there was no need. You can also find the 31st term, and if you know the 31st term, you can use this formula the way that you know it. If you know the 31st term, it'll be the first term of the second set of 30. Okay. All right, guys. So this is it. This is how you attempt your questions on sequences and series. So for 25 marks, this is what you are supposed to do. Okay. So I hope, guys, you enjoyed this, and this somehow is giving you confidence into these kind of topics. So bye bye.